Section 3, 4, zeros of a polynomial function. So we're going to start off, we talked about finding the zeros, and that's where the x-intercepts happen for a function. It's what number you can plug into a function to make it zero. Talked about synthetic division. So if polynomial is not quadratic, you can figure out possibly ways to break it down and factor it some. All right, so to start off this lesson, we're going to talk about the rational zero theorem. All right, and somebody figured out that, hey, if there is a rational number, okay, which a rational number, again, is a number that can be written as a fraction, so either a number like -3 or 2 or like 1/2, okay, all those are rational. If there is a number that is a rational number that is actually a zero or an answer to a polynomial function, then it has to be of this form right here. Okay, that top number will be factors of the constant term, which is the term at the very end, and we call that the p, or the p's. And the denominator, the bottom number of the fraction, has to be a factor of the leading coefficient. Okay, that's the number in front of the variable with the highest exponent. Okay, and so that really narrows down your choices from an infinite number of choices to a handful. All right, so this is how we do it. Okay, if you want to list all the possible rational zeros, first you got to realize for your p's, you look at the constant. Okay, you say, hey, what are the factors of 4? All right, it turns out those are going to be positive or negative 1, which goes with a positive or negative 4, because you could have -1 times -4, or +1 times +4. And then also a positive or -2, because 2 times 2, or -2 times -2, is equal to 4. Okay, and it's very important we have the positive or negatives there. All right, and then for our q's, we look at the leading coefficient. So here the highest exponent is 4, and the number in front of it's a -1. And so the only ways you can multiply to get -1 is going to be a +1 times a -1. All right, so those are our p's and q's. And then our possible rational zeros, which I like to abbreviate as PRZ. Possible rational zeros. Takes a while to write that out, so I usually like to abbreviate it as PRZ. Is you take all your p's and put it over all your q's. In this case, we only have the one pair of q's there, the 1. And so we take the p, all the p's, and say, all right, well, what's 1 over 1? Which that gives me 1. And so that's going to be positive or negative. We take the 2 over the 1, which gives me 2, or positive or -2. And then 4 over 1. So that gives me a positive or -4. And so if there's a rational number that makes this function 0, it's got to be either one of these 6 numbers. 1, 2, 4, or -1, -2, and -4. All right, any number like 3 or 5 or 1/2 is not going to work. If one of them works, it's got to be one of these. Okay? Doesn't mean that all of these or any of these actually work. We could have sometimes imaginary answers. Okay, but if something does work, or we could have numbers that aren't rational, but if a rational number works, it's got to be one of these 6. So it's not too hard of a process there. Now let's take a look at one where you have an actual number in front of the highest exponent. All right, so we look at the constant. That's where we get our p's from. So our p here is going to be positive or -1 and positive or -2. And then our 15 is our leading coefficient, so that's our q's. All right, so it's going to be 1, which goes with 15. And I kind of just like to write them in numerical order. And then 3 goes with 5. All right, and then we write out our PRZs, or possible rational zeros. All right, so the way I like to do it in order to keep track of it, just keep organized, is I like to take one P and go through all the Q's, and then go to the next P and then go through all the Q's. That way I know I haven't missed anything. So I've got the 1 over the 1, so that gives me positive or negative 1. I'll take the 1 over the 3, which gives me positive or negative 1/3. Put the 1 over the 5, which gives me positive or negative 1/5. And I put the 1 over the 15, which gives me positive or negative 1/15. All right, so I've taken the 1 and gone through all of the Q's, and I'm going to go through the 2 in all the Q's. So 2 over 1 gives me 2. 2 over 3 gives me 2/3. 2 over 5 gives me 2/5. All these are positive or negatives. And then 2 over 15, which gives me 2/15. All right, so there's quite a lot of possible rational zeros. 1, 2, 3, 4, 5, 6, 7, 16 of these. Okay, but it definitely narrows it down from a whole bunch, from an infinite number. All right, so here comes the main part here. Finding the zeros of a polynomial function. All right, so what you do is you first find the possible rational zeros. All right, so your P's, again, that's 6, which gives me 1 and 6, and then 2 and 3. And then since there's not a leading coefficient in front of the x3rd, that's an understood 1. And so the Q is going to be 1. So our possible rational zeros are going to be all of my P's over 1. So that basically just gives me 1 over 1, which is 1. 2 over 1, which is 2. 3 over 1, which is 3. 6 over 1, which is 6. All right, so we have no clue what the answers to this one are, but I can break it down and figure out, hey, here's some numbers that might work. There's no use trying any of the other numbers. All right, so once we find that, we just start trying them, okay? We throw those numbers in there, and what we're looking for is, when I plug one of these numbers in, I want to get 0. So if I plug 1 in, I get 1 to the 3rd plus 2 times 1 squared minus 5 times 1 minus 6. So I'll work that out. That gives me 1 plus 2 minus 5 minus 6. All right, and that ends up giving me, let's see, 3 minus 11, which is negative 8. That's not 0. All right, so I throw that off of there. Doesn't work. So maybe I'll try the negative 1. Will a negative 1 work? Negative 1 cubed plus 2 times a negative 1 squared minus 5 times negative 1 minus 6. Negative 1 cubed is negative 1. Negative 1 squared is 1 times the 2 gives me positive 2. Negative 5 times the negative 1 gives me a positive 5. And then I get the minus 6. When I add those together, I get 0. So I found one of the answers. Okay? And remember we talked about in another lesson, whatever the exponent is the number of zeros that you're going to have. Okay? Some of them could be imaginary, but this is, you got to have 3 of them. All right, so once we find one of them, we can do the synthetic division we talked about in the previous lesson. We put the negative 1 in, our coefficients, 1 for the x cubed, 2 for the x squared, negative 5 for the x, and then our negative 6 constant. Don't forget any of those signs. And then you do your synthetic division. You bring down the 1, multiply it by the negative 1 to give you negative 1. 2 plus a negative 1 is 1. 1 times a negative 1 is negative 1. Negative 5 plus a negative 1 is 6. or negative 6, excuse me. Negative 1 times negative 6 is positive 6, which gives me 0, which I need to have that 0 there. All right, so that means our original function, x to the third plus 2x squared minus 5x minus 6, can now be broken down into x plus 1. Okay, that's from the negative 1 being one of the answers. You just put it in parentheses and change the sign. And then our answer, or our quotient from the synthetic division, goes down from a degree. So instead of x to the third, we have 1x squared. All right, the 1 is our linear coefficient, so 1x. And then minus 6. All right, and then we factor that quadratic. All right, so we got to find a number that multiplies to give me the negative 6 and also adds together to give me a positive 1 here in the middle. All right, and so we're going to go with a positive 3 and a minus 2. So 3 minus 2 is 1, and 3 times negative 2 is negative 6. So once it's factored, you set each one of these equal to 0. X plus 1 is equal to 0. Subtract the 1. We already knew this one. Negative 1. X plus 3 is equal to 0. We subtract the 3. That gives us negative 3. And then x minus 2 is equal to 0. We add the 2. We get x is equal to 2. So our three answers here are negative 3, negative 1, and 2. All right, which we could not do any kind of factor by grouping, at least not obviously when we look at it. Okay, but using possible rational zeros, the remainder theorem here, to figure out which one works, and then using synthetic division to break it down and then factor it. All right, you can pause it, work the checkpoint problem, check it out problem, and then I'll have the answer in a second. All right, so here's the answer to that one. You can pause it and look through the work if you need to. All right, so let's look at this one. Another one of these problems. So again, we find our p's and our q's. Our p, what multiplies to give me 3, which is either going to be 1 or 3. And our q's, what's the number in front of x cubed, which is 1, so just 1. So our possible rational zeros are going to be the 1 over 1, which is 1, and the 3 over 1, which is 3. All right, and we start plugging in to find one of them. So we need to find that first 0. So if we plug 1 in, we get 1 to the third power, which is 1. We get 1 squared, which is 1 times the 7, so plus 7. 11 times 1, which is plus 11. And then minus the 3. All right, since we got a whole bunch of positive numbers and only the 1 minus 3, it's not 0. Turns out it's 16. So I know that one doesn't work. We try negative 1. Negative 1 cubed is a negative 1. Negative 1 squared times the 7 gives me plus 7. Negative 1 times 11 gives me minus 11. Sure I'm doing all of this right. And then the minus 3. All right. Turns out this one's not going to work either because we got 3 negative numbers, which add up to, well, it all adds up to, let's see, 6. It ends up giving me negative 8, so that one doesn't work. So we try 3. Will 3 work? Well, 3 to the third is 27. 3 squared is 9. 9 times 7 is 63. 3 times 11 is 33. Minus the 3. I am not sure exactly what that is, but I know it's not 0 because I got all these big positive numbers and just the minus 3. So that one doesn't work. So hopefully we'll find it on the negative 3. All right, if not, there's just not going to be any rational numbers at work. All right, when you cube a negative 3, you get negative 27. When you square the negative 3, you get positive 9 times the 7 gives you 63. Negative 3 times 11 gives me minus 33. And then the minus 3. All right, and then when you stick that in your calculator, okay, and the way I kind of like to do it in my head, I got all the negative numbers. Negative 27 and negative 33 give me a negative 60. Minus the 3 give me negative 63, which will add to the 63 to give me 0. So that's our one that works. All right, so we do our synthetic division. Put the negative 3 in the box. Got 1, 7, 11, and negative 3 as our coefficients and constants of our function. We bring down the 1, multiply by negative 3, add to give me 4. That gives me negative 12. Add to give me negative 1. Gives me 3 and 0. So our original function factors into x plus 3 because negative 3 worked. And then x squared plus 4x minus 1. All right, and once we get down to a quadratic, we can either factor this, which this one won't factor, or we can use quadratic formula, which I know you all love. Okay, so I know that we have x plus 3 is equal to 0. So when I subtract the 3 over, that gives me a negative 3. That's one of my answers. All right, but if you remember quadratic formula, x equals negative b plus or minus square root of b squared minus 4ac all over 2a. All right, we're going to use that on this quadratic here in the second parentheses. Our a is 1, our b is 4, and our c is negative 1. All right, so we plug it into that quadratic formula. We get x is equal to a negative 4 plus or minus the square root of 4 squared minus 4 times 1 times negative 1 all over 2 times 1. So we get negative 4 plus or minus square root of 4 squared is 16. Negative 4 times 1 times negative 1 is positive 4 all over 2. If we add the 16 and the 4 together, we get 20. All right, and since 20 is not a perfect square, but it does break out into 4 times 5, and 4 is a perfect square, that gives me negative 4 plus or minus. The square root of 4 gives me 2, and then that 5 stays underneath the square root. And once you have that radical simplified, you can look at all the numbers outside the radical and say, hey, are all those divisible by the same number? And in fact, they are, so you can divide each of those numbers by 2. And so you have negative 4 divided by 2, which gives me a negative 2, plus or minus the 2 divided by 2, which gives you 1, times the square root of 5. And so your answers are negative 3 from original, and then negative 2 plus the square root of 5. You don't have to write that 1 in front of it, and then negative 2 minus the square root of 5. Okay, so it's using stuff we learned previously along with the stuff we've just learned. All right, pause it and try the next problem, and then look at the answer. There you go. All right, these are fun, I say sarcastically. And we have something x to the 4th. All right, so there's going to be 4 answers, so there's going to be more to do here. All right, but same process. We look at our p's, factors of 24. Oh, there's a lot of them. We've got pot 1 and 24. We've got 2, and we've got 12. We've got 3, and we've got 8. And we've got 4 and 6, and all those are positive or negatives. Our q's, we've got the 1 here in front of x to the 4th, so 1. So our PRZs are all of those numbered with positive or negatives. You're like, oh my goodness, that's a lot of them. So positive or negative 1, positive or negative 2, positive or negative 3, positive or negative 4, positive or negative 6, positive or negative 8, positive or negative 12, positive or negative 24. And we just go through and work until we find one that works. So, let's try 1. 1 gives me 1 to the 4th, which is 1. Be a minus 6, as 1 squared is 1 times the 6. Minus 8 plus the 24. Okay, that does not give me 0. We got a negative 14 for the negatives and 25. Okay, I'm also not going to try negative 1. Okay, just looking at the numbers here, there's no combination. Even though I put these 3 together, the 1, 6, and 8, if those are all the same sign, that's not going to counteract the 24. So 1 and negative 1 aren't going to work. So we try 2. All right, 2 to the 4th is 16. 2 squared is 4 times the 6 gives me a minus 24. 2 times the 8 gives me a negative 16. Because there's a minus in front, plus the 24. All right, so that one actually works. You can see 16 and negative 16, those will go to 0. And the negative 24 and the positive 24 will go to 0. So do synthetic division. We put 2 in the box. Got 1 for the x to the 4th term. There is no x to the 3rd, so we have to put a 0. Don't forget that. We have a negative 6 for the x squared term, negative 8 for the x, and 24. We do our synthetic division. Bring down the 1. Multiply it by the 2. Add that to the 0. Multiply by the 2. Add that to the negative 6. Multiply it by the 2. Add that to the negative 8. Multiply that by the 2. All right, and we do in fact get that 0 as our remainder. So our original equation is now broken down into x minus 2. And then since that was a 4th term, 4th degree, we go down by a degree. We have 1x to the 3rd plus 2x squared minus 2x minus 12. All right, but notice here that our besides our x minus 2, we still have cubic, so we got to do the whole process again. All right, now I'm not going to waste time by finding more PRZs, because if you look at it, my P is the 12 and the Q is the 1, so it's just going to be a subset of these up here. I know it's not going to be positive or negative 24 because that's too big for 12. All right, 8 doesn't go into 12. 6 does, 4 does, 3 does, 2 does. And then we can actually cancel out the 1s because we already knew those don't work. And if they don't work for the first one, they don't work now. So we just try from these leftovers to see if any of these work in the x to the 3rd problem. All right, so let's try it out. Let's try the, we'll actually try the 2 again. Because sometimes, as you noticed in a couple of lessons ago, sometimes it happens more than once. So plug the 2 into the x cubed part. I get 8 plus 8. 2 times 2 is 4, so minus 4 minus 12. All right, and it actually gives me 0 again. So 2 worked out twice now for us. We do synthetic division again with this set of coefficients. Got 1, 2, negative 2, and negative 12. Bring down the 1, multiply by the 2, add together with the other 2, multiply by 2, add to the negative 2, multiply again by the 2, which gives me 0. So now we know our function is x minus 2 from the first 2, x minus 2 from the second 2 that worked. And since we went from a cubic down to the next one, we have 1x squared plus the 4x plus the 6. And once you get it down to a quadratic, you can solve that out by either factoring, which this one won't, because there's nothing that will multiply to give me 6 and add together to give me 4. Okay, and so we're going to have to use quadratic formula again. So remember, a is 1, our b is 4, and our c is 6. So to find our other 2, we use quadratic formula. X is equal to a negative b, so negative 4, plus or minus the square root of the b squared, so 4 squared, which is 16, minus 4 times our a, which is 1, times our 6, which is c, all over 2 times 1. So negative 4 plus or minus 4 times 1 times 6 is 24. When you subtract that from 16, you get negative 8 all over 2. All right, we got 2 problems here. We got a negative, and 8 is not a perfect square. All right, but you do have the negative 1, and then 4, and then 2. So negative 4 plus or minus. The square root of 4 is 2, so it comes out. The square root of negative 1 was that I, the imaginary number. And then you'll still have that other 2 left underneath the square root, all divided by 2. And then you look at the numbers outside of the radical. You don't mess with the radical. They're all divisible by 2. So it ends up giving you negative 4 divided by 2, which is negative 2, plus or minus 2 divided by 2, which is 1. So we can just say I square roots of 2. So our answers are 2, which has a multiplicity of 2 from over here, and then negative 2 plus I square roots of 2, and negative 2 minus I square roots of 2. So we do have 4 answers here, since 2 had that multiplicity of 2. And we have 2 imaginary answers. But that do give me 4 answers. All right, a lot of work there, a lot of places to make mistakes and just get tired doing it. Okay, but if you do it step by step, I promise you can get it. All right, there's the answers to the next one. All right, and so example 6, we're going backwards. We're going to find a 4th degree polynomial, so we know we want to get up to x to the 4th. And they tell us, with real coefficients, and that they tell us the zeros. Negative 2, positive 2. They also tell I as a 0. Okay? And so the 4th degree tells us I have to have 4. And they've given us a negative 2 and positive 2. And they've also given us I. All right, but it turns out that if we have an imaginary answer, all right, the negative or the conjugate of that, which in this case is just going to be negative I, will also be an answer. All right, so if we had 3 plus I, this is just not for this problem, but 3 plus I was an answer, so would be 3 minus I. Okay, and the conjugate is changing that sign in the middle. If you look at the previous example, notice that our imaginary answers look exactly the same except one of them has a plus in the middle, one of them has a minus. All right, that's always going to happen. On this one we have plus, minus. So there's our 4 zeros, and we're going to use that to work backwards. Okay? And so what you're going to do is you're going to write out f of x is equal to, you're going to write a. All right, and the reason we got a is because we need to make sure that this is true. So there might be a number in front that scales the whole thing. So we'll just put the a and leave it there, and we'll figure that out at the end. All right, and then for each of our zeros, we're going to say x minus that. So x minus the negative 2, x minus the positive 2, x minus the I, and x minus the negative I. All right, each of our 4 answers. All right, clean that up. It becomes x plus 2, x minus 2, x minus I, x plus I. All right, and then we need to multiply that out. Okay, and so I'm going to do them in pairs. Okay, I'm going to multiply the first 2 together. I'm going to multiply the second 2 together. All right, again, our a is just hanging out. When we multiply or FOIL that first pair, we have x times x, which is x squared, x times negative 2, which gives me negative 2x, 2 times x, which gives me positive 2x, and 2 times negative 2, which gives me minus 4. All right, and I'm going to do my imaginaries. Make sure you pair up the imaginary ones. Make it easier. X times x gives me x squared. X times I gives me ix. Negative I times x gives me minus ix. And negative I times I gives me a negative I squared. Clean that up, we have a. End up having x squared minus 4, because these two cancel out. And then we'll have x squared. The ix and minus ix cancel out. And remember, I squared is negative 1. We learned that a long time ago. I squared is equal to negative 1. So negative 1 turns that into plus 1. All right, and then we could FOIL those two. So the a is still hanging out. X squared times x squared gives me x to the 4th. Outside gives me 1x squared. That's the x squared times the 1. A negative 4 times the x squared gives me minus 4x squared. A negative 4 times the 1 gives me a minus 4. Okay? All right, once we're here, we have our 4th degree polynomial. We have that x to the 4th. We just got to make sure we know what the a is. Okay, and so that's where we're going to use this last little fact here. We know f of 3 is equal to negative 150. So we're going to set the negative 150 equal to our polynomial here, a. But instead of x, we're going to plug in that 3. Because it says when I plug a 3 in for x, I should get negative 150. So 3 to the 4th power plus 3 squared minus 4 times 3 squared. I guess I should have put those together and made it a little easier. Minus 4. So negative 150 is equal to 3 to the 4th. That's 81 plus 9. That'll give me minus 36 minus 4. So negative 150 is equal to a times, all right, 90 minus 40, which is 50. And then when we divide the 50 over there, we get a is equal to negative 3. All right, so once we have that, we're almost done. we have our function is a -3 times, because that's our a, times the x to the fourth stuff. So we get x to the fourth. Go ahead and put these together. X squared and 1x squared and -4x squared will give me a -3x squared. And then -4. And then last, we distribute the -3 through. So our final answer is a -3x to the fourth. -3 times -3 gives a plus 9x squared. And then -3 times -4 gives me a positive 12. And that is our answer. So to summarize, we have the zeros. We'll write our function, put an a out in front, write x minus each one of our zeros, multiply that out, and then we use our initial condition that f of 3 is -150 to figure out what the a is, and then we rewrite. Again, there's some hard stuff in this lesson. All right, you can pause it and wait for the next answer. All right, there it is. All right, and to finish this out, we're going to talk about Descartes' signs. All right, this is just another tool in your bag of tricks to help you realize what answers could be. So Rene Descartes, who's responsible for graphing, pretty much, and other stuff, he figured out that if you count the number of sign changes in your problem, okay, if you look at the polynomial all the way out and count the number of times the signs change, okay, that's going to give you the number of positive real zeros, so the positive answers that are real that will work. Or, since we have our imaginary answers come in pairs, you can go down by 2, okay? So if there were 4 sign changes, you could have 4 answers that are positive, 2 answers are positive, or 0 answers that are positive. Okay, so you keep on subtracting 2 from that number until you get down to 0. All right, and for negatives, we just plug a negative x in, and then we do the same process. All right, so here's kind of a little chart that kind of shows it. Notice we have 3x squared, it was positive, then it changed to negative, then it stayed negative, and then it changed to positive, it stayed to positive, and then it changed to negative. So we have 3 sign changes, so that means there's either 3, or if you say 3 minus 2, there's 1. So either 3 or 1 positive real zeros. All right. So let's do our problem here. All right, so if we look at this one, we have positive x to the third. It stays positive. It stays positive. And it stays positive. So since there are no sign changes there, so we have 0 sign changes, that means that there are no positive real roots. So if we were to actually solve this problem out, we would know, hey, don't even try those positive numbers. They're not going to work. Okay, and roots is synonymous with those zeros. All right, now for the negatives. We plug a negative x in. So that's a negative x to the third power plus 2 times a negative x squared plus 5 times a negative x plus 4. All right, when you cube a negative, it becomes negative, so negative x to the third. When you square a negative, it becomes positive, so this stays plus 2x. 5 times a negative x gives you minus 5x, and then the plus 4. All right, and now we count the sign changes. Starts out negative, and then it changes to positive. Then it changes to negative, and then it changes back to positive. All right, so there's 3 sign changes. And so that tells me there's either 3, or if you subtract 2 from 3, you get 1, negative real zeros or real roots. All right, so all our answers are either going to be negative or they're going to be imaginary on this one. So no positive zeros or no positive roots, and then either 3 or 1 negative. All right, those are the answers. Hopefully this worked out. You can rewatch it, rewatch sections of it. Here's the answer to the last problem. All right, good luck.